With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the podcast Space Nuts, episode 101. We made it past 100. We don't feel any older. My name's Andrew Dunkley, and joining me as always is Dr. Fred Watson from the Australian Astronomical Observatory. Hello, Fred.
How are you doing, Andrew?
I am quite well.
Yeah, I'm glad to hear you're not feeling any older. I feel older every day.
Yeah, I think it goes with the territory.
Yeah.
You look at such old stuff. I mean, it's got to rub off.
Yeah, rubs off a bit, yeah.
Now, today, we've got some exciting things to talk about. One is the Australian federal budget. I was just listening for the crickets. But there's exciting news within that for your organisation. So we're going to briefly mention that. We're also going to talk about galactic mergers, ancient galaxy mergers. Now, we do know, and we've talked about before, the merger between our galaxy and the Andromeda galaxy, which is happening next week, or is it in a couple of million years? But we'll get around to it. But this is these are mergers that happened way back, and they've now been able to find out more about them. We also are going to look at another cataclysmic event, and that is a supernova. But they've found through again your telescope evidence of a survivor of a supernova, which is very exciting. And finally, we'll wrap up with a listener question. This comes from an airline pilot who wants to know a bit more about Noctilucent clouds, and she's even sent us a photo of one she took over Russia, which I will try and get put online so you can have a squiz at what she's got. It's amazing. Anyway, we'll get to that a little later. But first, Fred, budget news. Dun, dun, dun.
Yeah, who would have thought that we would have been celebrating the budget? But we are.
Not many people do.
No, that's right. Excuse me. The 2018 federal budget contains what's being described as seed funding for the new Australian Space Agency. You and I have talked about the Space Agency before, and we've probably said more than we should on what it might be called, whether it's ASA or it's not like NASA. And there are other acronyms that people have suggested.
Yes, there were a few real rippers, not fit for broadcast.
That's right. So, yes, we've talked about it before, but it's now a reality, Andrew.
Well, Shazza was a good one. Shazza was a really good one. Very Aussie.
The Shazza, the Southern Hemisphere one.
Yeah.
So what's the story? Well, the government is going to put $50 million into the new space agency. We also now know that the director for the first year will be the former boss of the CSIRO, Dr. Megan Clark. She has basically been charged, or she was charged last year, with undertaking a review of Australian space activities with the idea of pulling all this together under the umbrella of the Space Agency. And to some extent, her review was upstaged because they announced the review last July, and in September they said, well, we're going to have the Space Agency anyway. But now what's happened is that the announcement has been made. We know much more about what the structure of the Space Agency might be. What we don't know is where it's going to be yet. A number of states have put their hands up to host the new space agency. In some ways, that doesn't matter because when you're dealing with space, the whole world is part and parcel of it.
Yeah.
But of course, there are centres of activity within Australia, and actually South Australia is one of them. There's a lot of space work goes on down there. So,
well, historically, it's where we really started our space program in Woomera.
With Woomera, that's absolutely right. So there's all that tradition. There's new ideas. There's new industries. There's new space, enterprise going on, all of which will now come under the overall umbrella of the new space agency. The thing, and just winding this little bit up because it's really just a news flash item. But the thing that is, I think, really promising is what we might earn from this, because we in Australia currently generate round about $4 billion worth of activity in the space industry, and that covers everything from communications to building little CubeSats and all the rest of it. That is about 1% of the current global market for space activity, so it's round about $400 billion. There's now a forecast. It was made last year, in fact, but it's being reiterated that within three decades, so perhaps the next 30 years, that space industry is expected to be worth more than $3.5 trillion US dollars. So it's on its way up. It's a big ticket item, and we are going to be well placed in Australia to be part and parcel of that, along, of course, with all the other national space agencies around the world. I mean, we're never going to be a NASA, but we will always work with them, and the Japanese space agencies, and of course now the New Zealand Space Agency as well. So we've got a twin not very far away.
And we are planning to send a kangaroo to the moon.
Yeah, well, that's right.
Gee, imagine how far it would jump.
They do there, yes.
That would be extraordinary. Don't think you could find a helmet to fit its head, though. And how much was the budget figure?
50 million.
Which is just about Fred's salary. And that is it. All gone.
Dreams in your dreams. It's actually, I have to say, Andrew, it is more than I expected it to be. I thought it was going to be less than that. So it's a nice surprise.
It is indeed. Well, there'll be more to talk about as that develops. So that's terrific. Now let's turn our attention, Fred, to a couple of things, or one thing in particular at this point in time, involving a couple of telescopes that have been looking into deep space, and they have found evidence of massive conglomerations of forming galaxies in the early universe. This is quite a discovery.
It is, and it's another of these discoveries, Andrew, that, it's not quite rewriting the textbooks, but it's certainly involved with generating a major rethink of our ideas. So what's been observed, and you're quite right, it's in fact with a number of telescopes. Perhaps the most important of them is the European Southern Observatory's Atacama Large Millimeter Array Telescope, otherwise known as ALMA. ALMA sits up there 5,000 meters above sea level in the Atacama Desert, an amazing place. That's a radio telescope. So the instrument that's been used on ALMA has allowed astronomers to reveal that there is deep in space, which means far back in time, there is a kind of what is being described as a proto-cluster of galaxies. It's a cluster of galaxies, but it's clearly in a state of evolution because these galaxies are all packed tightly together, and the gravitational interactions between them, because they're so tightly packed, and also because there's such huge reservoirs of hydrogen as there was in the early universe, that's generating what we call starbursts, a starburst of star formation. And so this strange cluster that's been detected by these telescopes is unexpected because of where it is. And by where it is, I mean its distance from us. And by that, I mean how far back in time we're looking. Yeah. Just to recap, of course, whenever we look out into space, we're looking back in time. And in this case, we're looking back to when the universe was only about 1.5 billion years old. It's back to you're looking back almost the full age of the universe, which is about 13.8 billion years. Now, the sort of standard model of galaxy formation and galaxy cluster formation says that, yes, these intensely active clusters of galaxies should exist. That all the theoretical models predict that that's going to happen in the very early universe, where the sort of virgin hydrogen fuel that's in the early universe is starting to be used up in stars. So you would expect to see them, but you don't expect to see them until roughly 3 billion years after the Big Bang, not 1.5 billion years after the Big Bang, which is what these observations actually have revealed. So that is why it's back to the drawing board for the theoretical astronomers who model these things. It's like so many of the discoveries that we're making about the very early universe. We seem to be constantly finding that things happened earlier than we thought they did, like the first stars forming and things of that sort within the first billion years. So and I guess the reason for this, just to perhaps put a word of explanation on it, in case there are people out there thinking, well, you just got it wrong, didn't you?
That's exactly what I was thinking. I was going to say, could they have just made a mistake with their timing? I mean, 1.5 billion versus 3 billion. It's not a big stretch.
It's not. No, that's right. But what's happening, the reason why all this sort of stuff is showing up is that we now have bigger and much more effective telescopes that allow us to look back at these times, which we didn't have before. So when these models were being proposed, probably a decade or so ago, we couldn't see back this far with the kind of detail that we can now see. And so the information simply wasn't there, that you needed to be able to account for galaxy clusters occurring so early in the history of the universe. What it suggests, and this is a fairly naive interpretation, but naivety is one of my specialities, Andrew, as you know.
Oh, I'm in the same boat.
Yeah. What it suggests is that the early universe, and by that I mean within the first couple of billion years of the history of the universe, was a far more dynamic and active place than we envisaged. We knew it was a wild and woolly place because the Big Bang was still fairly recent history at that time, and so there was still this conversion of the radiation field turned into matter quite early on. But this process of hydrogen gathering together to form, well, first of all, stars and then galaxies, probably all effectively at the same time, this gravitational collapse of clouds of hydrogen to do all that seems to have happened much more intensively than we previously thought. And it's the new observations that are revealing that, thanks to new technology.
Yeah, it's quite extraordinary. And I still can't get my head around the fact that everything we're looking at is historical, and finding this, putting it, near the dawn of the universe, technically, is just mind-blowing. And even looking at near Earth objects, even the moon, we're looking back in time. The sun, we're looking back in time, in terms of seconds and minutes. But it's, we're not looking at what's happening there right now. We're looking at what happened there 7 or 8 minutes ago, or seconds ago, and that's basically the only thing in real time is what's happening right in front of us, before our noses, and then we look up into the sky, and everything we're seeing's
past history.
Millions of years old, billions of years old in some cases.
Andrew, when you look at me, you're looking straight back to the 1960s. But that's a different thing.
Yes, indeed. And as much as it entertains me to give you a bit of a serve in that regard, I'm going to let that one go through to the keeper, to use a cricket analogy. But yeah, it's pretty exciting stuff, and and with future telescopes still in the planning, there's probably so much more to discover, which is even more exciting.
Absolutely.
Yeah. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by Tech Radar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show. He's still here.
Zero G, and I feel fine.
Space Nuts.
Now, our next topic, Fred, involves your observatory yet again. We've talked about a few discoveries and findings, which is the same as a discovery, I imagine, involving the Australian Astronomical Observatory in recent times. This one comes from your part of the world, but it also involves the Hubble Space Telescope. And what we're talking about is a survivor from a supernova. Now, as I understand it, a supernova is a pretty big cataclysmic event, and I wouldn't imagine there'd be too many survivors, but you've found one.
Indeed, we have. That's right. And in fact, this is work led by my colleague Stuart Ryder, who sits in an office about 3 doors along from mine in Sydney. And he's got a team of people he's worked with, one of whom is a particularly interesting character because this story goes back to 2001, the 10th of December 2001, and to a very well-known Australian amateur astronomer, a man by the name of the Reverend Robert Evans. His day job was being a Uniting Church minister, but by night he was one of the world's best-known supernova hunters.
Ooh.
And that's a very special talent. But what Robert Evans did, and we call him Bob because that's what we call him, Bob was gifted with an amazing ability to remember sort of fields of stars in his telescope. So what he did was he sort of scanned pretty well every night, I think, around a long, long list of galaxies. And galaxies are, as you know, they're these objects we've just been talking about, gigantic things containing hundreds of billions of stars, and they're at very great distances. And in an amateur telescope, you can easily pick them up. They look like faint smudges of light. But of course, they're surrounded by stars, most of which are actually members of our own galaxy. So Bob had this real capacity to be able to memorize those fields of stars, which meant that as he went through his list of galaxies, if there was a new star in the galaxy, i.e. a supernova, he was the first to find it. And he had this incredible track record of visually finding supernovae, probably a longer list than anybody else in the world.
That's extraordinary. That is just amazing. Like a photographic memory.
It's almost like that. That's right. And in fact, sadly, that the requirement for that kind of memory has decreased because now all the amateur astronomers use electronic cameras, and all you do is feed your image from the electronic camera into the computer and ask it to compare the one you took last week, and if there's a new star there, it shows up immediately.
That's how they found Pluto, isn't it? Comparing two photographs.
Place. That's correct. Exactly.
Gosh, I'm good. I am.
You're very good. Do you remember the date?
It was 1930, wasn't it?
Yeah, February 1930.
Oh, 2 for 2.
Not bad, eh? Anyway, so this particular supernova that we're now discussing, if we ever get to the story, it rejoices in the
too
name.
busy showing off.
Yeah, there you go. It rejoices in the name Supernova 2001 IG. That's how supernovae are named. And it was found by Bob Evans. Bob, by the way, still going strong. He turned 80 last year, but he's still very keen on astronomy and lives in the Blue Mountains to the west of Sydney.
Not far from where I am right now.
There you go. That's right.
I also believe there's a singer-songwriter named Bob Evans, but that's a different story.
Oh, you're thinking of Bob Marley and the Wailers.
No, there's Bob Evans. I'm sure of it.
We do a lot of whaling in astronomy as well, especially when the weather's cloudy. Anyway, that an aside. So, all right, fast forward now. Fast forward a little bit, because when it was discovered, it was very quickly realized that this was an unusual supernova. It was something called a Type 2b stripped envelope supernova. And what that means, supernovae, as you might guess, come in different types, and a Type 2b is one classification. We normally think of supernovae as stars that have got to the ends of their lives and just run out of hydrogen fuel, and then they collapse and blow themselves to pieces in a spectacular explosion. And indeed, that's why you can find them with small telescopes, because they outshine their host galaxy very often. So, excuse me, this one was a slightly different type. A stripped envelope supernova means that most of its outer layer of hydrogen has gone before the explosion happens. So in other words, it's a star that's kind of evolved and it's blown its hydrogen off into space, probably in a fairly gentle way. But something has then happened to make it explode. So what is that something? Well, it's the inference is that there is another star, a companion star to the supernova, whose outer gaseous envelope is basically falling into the supernova star, if you see what I mean. Its gravity pulls it off. The star is close enough that you can have this exchange of matter between the two objects. So the stripped envelope supernova is sitting there, but it's pulling material off its companion. And when that material gets to a certain level, it becomes unstable and it explodes. And so you get the supernova explosion. Now, that's a scenario that's fairly well understood, but we've always thought that the victim of that sort of event would be the companion star, that there wouldn't be that much left after, this thing explodes right nearby. So this is where the surprise of the new observations come from. And we can now fast forward to the present time, because Stuart Ryder, my colleague, and his team have looked at supernova 2001 IG with the Hubble Space Telescope, some sort of 17 years after the event. And sure enough, the companion star is still there. For the first time, they have actually detected this surviving companion star.
That's amazing. And what sort of condition is it in?
It's probably a bit beaten up, but at least it's there. I don't think we have yet done detailed observations of that star, because it really, even in the Hubble telescope image, just appears as a faint smudge. It's not really giving us much to go by. But I'm sure this work will continue, and particularly once the Hubble telescope's successor, the James Webb Space Telescope, is launched in 2020, then we'll have a much bigger eye in space to look at some of these really interesting objects that are out there.
Yeah, it's quite a discovery, and I suppose that means that you may well be able to observe other binary systems and see if, or former binary systems perhaps, if you know where they are, and see if it's happened elsewhere or is likely to happen again. I'm sure it is. These things pop up from time to time. Some have been spectacularly recorded in history. They don't last very long. I suppose that's one of the things about supernova. You just you've got to be in the right place at the right time and look in the right part of the sky to catch them. That's right. In fact, usually, their period of peak brightness is a matter of weeks, if not days. It's a fairly brief rise to spectacularness, and then it's a question of
tracking down the way the light decays from the supernova. Yeah, but this is a very interesting story, and I'm delighted that it has the Australian Astronomical Observatory at its heart.
Lovely. And what did you call it? A stripped envelope, something or other?
Yeah. How's your stripped envelope? Well,
yeah. Well, it just goes to show that going to the opening of an envelope can be exciting sometimes.
Exactly.
All right. You're listening to Space Nuts, the podcast, episode 101 with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Finally, Fred, a listener question. This comes from Hannah. I'm a UK listener and I love your podcast. It's really fantastic, with about 17 exclamation marks after that. I'm kidding. I have a question which should be short and sweet. I'm an airline pilot and also a big space and cloud enthusiast. I've been fortunate enough to see some really amazing Noctilucent clouds, although in my 11-year career I've only seen them twice because the little rascals are so hard to catch. Below is a photo from a flight to Moscow. From what I understand, they're usually found just before dawn in the summer months. I remember hearing that there was a debate about whether they are made of space dust or ice crystals. If you get a moment, could you shed some light on this? And also, would you class them as space clouds or Earth clouds? Thanks, Hannah. Hello, Hannah. Thanks for the question. Airline pilot. Oh, I'm flying soon. I hope you're flying my plane. That'd be nice. Now, Noctilucent clouds. We've talked about these before, Fred. So Hannah's been lucky enough to see these. What can you tell us about what she's observed?
So Hannah's doing better than I have because I've never managed to see them. And just to kind of fill in the gap, what are Noctilucent clouds? They are clouds that shine at night, basically, but clearly, they've got to have some mechanism for doing that, and it's a bit like the same way that we see satellites. We always see satellites after sunset or before sunrise, and it's when we are in darkness, but the upper layers of the atmosphere are still being illuminated by the sun, which is below the horizon. So we see satellites by reflected light. Yeah. Now, Noctilucent clouds are not as high as satellites. They are still firmly in the atmosphere of the Earth, but they are far higher than any other clouds that we know about. They are, you can kind of draw a line at 10 kilometers or so for normal clouds. There's not much. There are a few cloud layers that take place above that, but these Noctilucent clouds are between 75 and 85 kilometers above the surface of the Earth. That's
extraordinary.
Very high indeed. Yeah, and when you think that, at 10 kilometers high, you're above 75% of the Earth's atmosphere, you're above a lot more of it when you're at 75 to 85 kilometers. No way that you would ever see them in daylight. They're very tenuous.
Hang on, Fred. For the Americans, that's 50 miles.
Oh, sorry about that. Yes. In fact, well, let's do it more accurately. 47 to 53 miles.
There you go.
I'm sorry about that. That's right. We've got to be multi-unit.
Yeah, we
people.
do. I'm glad we don't have to give time calls like we do on radio.
Yes, that's right. No, that's all right. The thing about them is that they're very sparse. They're fairly rare, as Hannah has suggested, that you don't often see them. And as I've said, I've never seen them. Normally, you see them not very far from the pole, sort of at latitudes maybe 50 to 70 degrees, both north and south of the equator. And that's because, well, partly because you get these very long twilights, particularly in the summer months at those latitudes. And in winter, you've got much longer nights at those higher latitudes. And so there is probably also, though, rather than so what I've just said refers to, how observable they are, whether you would see them if they're there. But of course, there is also the question that they probably do not occur at latitudes closer to the equator, because the fundamental mechanism that causes these is the condensation of ice crystals. So we know they're made of ice crystals, and that's sort of answering one of Hannah's questions, although in many ways the idea of dust is also right, because the dust particles, these are microscopic dust particles, might well act as nuclei for the ice to build up around them. So they are ice crystals, and that's what you'd expect. Cirrus clouds, which we see very commonly, are ice crystals as well. But these ones, the Noctilucent clouds, are probably much finer crystals. They probably don't have the same sort of structure that the lower ones do. So are they space clouds or are they Earth clouds? A really good question. They are clearly connected with the Earth because they occur at a particular height above the Earth's surface, but they are very near that boundary between the Earth's atmosphere and outer space, and so you could sort of look at them as space clouds. They've been well studied actually by the scientific community. Back in 2007, a spacecraft called AIM, and AIM stands for Aeronomy of Ice in the Mesosphere, which is where these clouds are. That was a satellite that was launched directly to study Noctilucent clouds, and it was the first one really to record them, and record the shapes of these clouds. But what I was going to say was the key thing that came from the AIM satellite was that the overall shape of these Noctilucent clouds is very similar to clouds at much lower levels, what we call tropospheric clouds, clouds that are, at the kind of cirrus level. So they've got similar shapes, and that suggests that the dynamics of the atmosphere that form them is similar. Even though the atmosphere is much more rarefied where the Noctilucent clouds are being formed, there's still the same sort of wind patterns and things of that sort that give rise to these Noctilucent clouds. So I think they are definitely Earth clouds rather than space clouds, but they're nearly in space.
Yeah, they are. They're just way out there.
Way out there. We also know that they occur around Mars as well. However, these are not, usually these are clouds, we believe that they're clouds of carbon dioxide crystals rather than water ice crystals as our Earth-based clouds are. But they go up a bit higher on Mars because Mars has lower gravity. They extend up to 100 kilometers or 62 miles above the surface of the planet. And in fact, they're the highest clouds discovered over the surface of a planet in terms of, the diameter of the planet itself.
Yeah. And of course, you look at gas giants, and they're basically made of cloud and gas. So
that's right.
That doesn't count.
It doesn't count.
No. It's interesting to me how Mars is so similar to Earth and yet opposite in many ways.
That's right.
Water ice versus carbon dioxide ice. Smaller planet with bigger geological features compared to us, and the night sky or the dawn and dusk sky is the opposite colour to ours, and it's all just it's quite amazing. Bizarre.
And yet there are dramatic similarities, and you and I have spoken about this before, but Mars has got almost exactly the same tilt of its axis as we have.
Yeah.
It's got almost exactly the same day, 24 hours, 40 minutes. And it also has almost exactly the same land area because there's no ocean on Mars. So the land
like
area...
I said to you last time, Fred, it sounds like someone was practicing before they
made the Earth. Yeah.
made the Earth. It's very, very interesting.
Could be right.
Yeah. It's certainly make a good discussion/debate, I reckon.
That's right.
Yeah.
I'd recommend reading The Hitchhiker's Guide to the Galaxy, and you'll prove that somebody did make the Earth.
Yes.
Started up fast, did the fjords.
The white mice orchestrated the whole thing, and the answer is 42.
42. That's
and
right.
The answer to your question, Hannah, we hope you have provided, and we hope we have provided for you. And if you don't agree with us, then the answer is 42. But keep the cards and letters rolling in, and we do appreciate your feedback, which is ongoing. Oh, and thanks to everybody who congratulated us on our 100th episode. That's very nice of you. We do appreciate it. Fred, thank you. It's been fun as always.
and fun talking to you too, Andrew, and I hope we can do it again soon.
I hope so as well. Fred Watson from the Australian Astronomical Observatory, and thank you again for listening. Don't forget to tell your friends and spread the word and share us on Facebook and all those other platforms that we seem to pop up on. There's so many I can't even remember what they are. And we'll catch you next time on the podcast known as
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.